Hey guys, welcome to today's video. In this video we are going to continue our previous discussion regarding LRU cache. So whoever haven't watched the previous video, please go and watch. Just for a recap, I'll let you know. This is question number 146 of the LeetCode top 150 interview question, and the question is LRU cache and it comes in a medium. So we have already discussed what this do and what is the functionality we wanted to achieve. So in the previous video we have solved this question of least recently used using the linked hash map and by implementing the remove eldest entry. So this is not exactly what the interview is looking for. The interviewer is looking for the implementation of the main functionality, that is remove eldest entry. So we are going to solve in this video using the doubly linked list and the hash map. So why we are going to use the doubly linked list and hash map? So let's understand it. In this we need to get the three things clear, which first one is getting the value, second thing is putting the value or adding the value to the list, and the third thing is deleting the value. And we need to have all these three operations in O of one time complexity. That is the requirement. Okay, so now for putting and deleting we will be getting it in O of 1 via the linked list, okay, via the doubly linked list. And the get operation we will use the hash map. Okay, so we are going to, in Java, for get we are going to use the hash map. In your programming language it can be anything like a hash table or something. So we are going to save the value in the map, okay, as a key, and the node will be our value. So node will be, suppose node 1 or node 2, and the keys will be 1 2 3. So whatever is the value of the we are saving as a key, right? So our get is done. This is how our get we will take from O of 1. Now for this put and delete we are going to use the doubly linked list. Okay, now for creating the doubly linked list we are going to have two node values, that is one is called the head and another one is the tail. Okay, currently our head will point to this and our tail will point to the last value. Okay, for the initialization state, this is our data. Now for if we will going to add any node, it will be in between. So every tail or head, it will have three values. One, it will have the data, another one is the post or the next value, and or the previous value or the pre. This will happen for both the tail and the head both. Okay, all will have the post and the pre value. Similarly, the node will also have, the node which you are going to add will also have the post and the pre value. Okay, for the first state, for the initialization point of view, when we were going to start creating the doubly linked list, so what we will only have the head and the tail value. Okay, now what we will do, we will point the post of the head to the preview of the tail and the preview of the tail to the head. So that's how we are creating the doubly linked list. Okay, so now if we are going to add any node, then we are going to dereference and rereference these values such that our head will point into the node and it will point vice versa. That's how we create a doubly linked list. We need to make sure that we will always add from the head and we will always delete from the tail. Now since we have understood why we are going to use the doubly linked list and the hash map, so let's start implementing this. Okay, so I'll just clear this up. Okay, so for LRU cache we are going to create a node. Okay, so this will be a custom node, so I'm just naming as LRU node. Okay, so this will have our key, our value, and the pre which will save the address of previous node, and this is the post, which will save the data regarding the next node. Okay, now let's come to this this LRU cache constructor. So for initializing, we need some more instance variable, that is int count. Okay, private int capacity. Okay, so our cache, that is our map of key and LRU node, we can name it as cache. To new hash map. Okay, and two variable, that is head and tail. Okay, now in this constructor we are going to initialize all those things. So count will be 0, our capacity will be the given capacity. Okay, now we are going to initialize head and tail. So how we are going to initialize it? So currently we have only two node in. So currently we have only two node in our doubly linked list. We can initialize it head equal to new of LRU node, and our head dot pre is null. Okay, similarly for tail, we are going to initialize with the new node, and our tail dot post is equal to null. Okay, now head dot post for now is our tail, and our tail dot pre for now is our head. That's how it become a doubly linked list. Okay, now let's solve the simplest one first, that is the get operation. Since we are getting the key over here, okay, so we are going to retrieve our node from the cache, since we are saving the key and the node both. So get of key. Okay, so if the node is equal to null, return -1, else return node dot value. So this is the similar way how we have done previously, but the thing is that whenever we do the get operation, we access the value. So in this case we have used it, so we need to make it to the top. Okay, so what we are going to do, so since we have accessed this value, we are going to move to head this value. Okay, so we're going to pass the node and we are going to move it to the top. Okay, so now we are going to implement this move to head. So now, so what does moving to head means over here? So you are removing that particular node from the doubly linked list and you are adding to the head. So this is what moving to head means, right? So it means that we are performing here two operations, that is removing the node from doubly linked list, okay, and add to head. So these two operations are required, right? So let's just sudo name it remove node. Okay, so we need to pass the node over here as well. Sorry. Right, so we're going to pass the remove node and add node. So these two operations we need to perform. So this means moving to head. Okay. Now we are creating these two methods. Okay. So let's name it remove node, and it will have LRU node value. So now in this, what we are going to do, so we are going to get the pre-node from this node, okay, and the post node from node dot post. So now pre dot post will be our post, right, and our post dot pre will become our pre. Okay, so that's how we are removing the node, and this is of one operation. Okay, now second one is adding the node. So similarly, we'll create one more method, add node, which will take LRU node as a value. So here what we are going to do, since we are always having the nodes, since we have initialized these things over here, so we'll always have a head and we will always have a tail. Okay, so now we need to add to the head. So now our node dot pre will become our head. Okay, this is one thing, and our node dot next value will be our head dot next value. It will not become tail, okay, because there can be it might or might not be the first element we are adding after between the head and tail. So it needs to be head dot post and not the tail. Okay, now so this is one way we have created a arrow. Now the opposite, because we need to create a doubly linked list, right? So we need to add head dot post dot pre is equal to node, and our head dot post will become the node. Okay, so we have completed our moving to head function. Okay, now our get operation is done. Okay, now coming to put operation. So in this put operation also there are two things, right? So if we get it from the cache, okay, there's one if is if we get from cache, okay, else if we didn't get from cache. If our count is greater than capacity, okay, and in this also if capacity has exceeded, then pop from tail. So after doing all this, since we have accessed this value, so we need to move to head. Okay, now let's write this. So if we get it from the cache, so let's first try to get it from cache. Okay, so if we get it from the cache, if is not equal to null, so if our node is not equal to null, then what we are going to do, we are just going to update the value is equal to the value which is given, the new value, and move to head this node. That's how we make it like it is accessed now, right? Now if we didn't get from the cache, then what happens? So we are going to create, okay, sorry, we are going to create a new node as name LRU node. Okay, now new node dot key is equal our given key, new node dot value is the given value. Okay, we are going to add the value in the cache. Okay, key and the new node. Okay, and now we are going to add node to the head. Okay, this new node. So now we have added, and now we are going to increase the count plus plus. Okay, so we have added our value. Now we will check if our current count have exceeded the capacity. Okay, so we will check if our count has exceeded the capacity. Okay, so in this case we are going to get the tail value because we are always going to remove from the tail side, right? So we are going to get the tail value pop tail. So we're going to pop in this method and return the tail, and then we will remove from the cache as well. And decrease our count. Okay, so these things we need to do. So now we are going to implement this pop tail method. Okay, let's write over here private it will return as the node pop tail. Okay, so what it is going to get the tail, current tail dot previous value. Okay, and this dot remove node, the resultant one, and return res. Okay, so that's it we need to do. Okay, let's test this out. So it passed the test. Let's try to submit it. So it got submitted. Hope you understood this. See you in the next. Thank you.